Coefficients of Fourier series. We already know that the coefficient of Fourier series are a sub naught, a sub n, and b sub n. But now I'm going to derive the formulas for a sub naught, a sub n, and b sub n. Let's say f of x is a periodic function, which is defined in interval minus pi and plus pi. From the formula of Fourier series, a sub naught, a sub n, and b sub n are the coefficients of Fourier series. In some books or in some tutorials you may see that the interval is from 0 to 2 pi. This is one thing, whether you take it from minus pi to plus pi or from 0 to 2 pi, because the range from minus pi to plus pi is one complete cycle, and the range from 0 to 2 pi is also one complete cycle. So it's up to you whether you take minus pi to plus pi or from 0 to 2 pi. Let me derive the formulas for these three coefficients. Take a sub naught first. From the equation of Fourier series, just take integration on both sides with the limits from minus pi to plus pi. I just took integration on both sides with the limits from minus pi to plus pi. The function of x is defined in interval from minus pi to plus pi. I repeat it here. In some books or in some tutorial you will see that the limits is from 0 to 2 pi. But here the limit is from minus pi to plus pi. It's up to you whether you take it from 0 to 2 pi or from minus pi to plus pi. Now take integration on the right side only. Integration of a sub naught with respect to dx equals to a sub naught times x. Integration of cos nx is sin nx or n. Integration of sin nx is minus cos nx or n. Distribute the limits here. You see here that there are sin n pi and cos n pi. If you reflect back to the prerequisite lecture where I mentioned that sin n pi equals to 0, but cos n pi equals to minus 1 to the power n. If the power is odd, cos n pi equals to minus 1. But if the power is even, cos n pi equals to plus 1. But here in this case I have minus cos n pi minus cos minus n pi. So whether you take the power n in even or odd, it still equals to 0 here in this case. So all sin n pi and cos n pi equals to 0 here, and I left only with the a sub naught, which equals to 2a sub naught times pi plus 0 plus 0, because the terms of sin n pi equals to 0 and cos n pi equals to 0. Simplify the equation further. This is my formula for a sub naught. Just put it here. A sub naught equals to 1 over 2 pi times integral of f of x with the limit from minus pi to plus pi. This is the formula for coefficient a sub naught. Now I'm going to pick the coefficient a sub n and we'll calculate the formula. Again from the equation of Fourier series. Take integration on both sides with the limits from minus pi to plus pi. But this time I multiplied both sides by cos mx. Cos mx is a third trigonometric function. Just multiply both sides by cos mx, where according to the rule cos mx equals to 0 for all n and m values. Similarly, b sub n equals to 0 for all n and m. This is one reason. The other reason is that sin nx is odd, cos mx is even. So odd times even equals to odd. In Fourier series, odd function equals to 0. Don't worry, you're going to learn the odd and even functions of Fourier series in upcoming lecture. So these two terms equal to 0. And I left only with this term, cos nx times cos mx. But there is a certain condition that you must know, that this term equals to 0 if the value of n is not equal to m. This term will be pi if the value of n equals to m. Let's suppose that the value of n equals to m. So this term equals to pi then, because condition says that if the value of n equals to m, then it equals to pi. And similarly, a sub n will be a sub m. Simplify it further and finally you will have a sub m equals to 1 over pi times integral of f of x times cos mx dx. Let me put back the n. Just replace m by n. This is my final equation for a sub n. Just put it here. A sub n equals to 1 over pi times integral of f of x times cos nx dx. This is the formula for the coefficient a sub n. Now I'm going to pick b sub n, again from the equation of Fourier series. Take integration on both sides with the limits from minus pi to plus pi. This time multiply both sides by sine mx. Just multiplied both sides by sine mx. Now according to the rule, sine mx equals to 0 for all the values of n and m. And similarly this term equals to 0 for all the n and m values. Because sine mx is odd function, cos nx is even function. Even times odd equals to odd function. And in Fourier series, odd function equals to 0. These two terms will be 0, and I left only with the last one, b sub n. But again there is a rule, this term will be 0 if the value of n is not equal to m. But it equals to pi if the value of n equals to m. Let's suppose that n equals to m. Therefore this term will be pi. I have b sub m times pi. When n equals to m, then the term will be pi. So is b sub m. Simplify the equation. This is my final equation. B sub m equals to 1 over pi times integral of f of x times sine mx dx. But I want to put n back, so let me put n back here. Just replace m by n. This is going to be my final equation for b sub n. Just put it here. B sub n equals to 1 over pi times integral of f of x times sine nx dx. So the formula for the coefficient a sub naught is here. And the formula for the coefficient a sub n is here. The formula for the coefficient b sub n is here. That is how I derived all the formulas for the coefficient of Fourier series.